Hello again. Yes, this is the third part for learning intention number 18 on drawing trigonometric graphs. We've done the sine graph, we've done the cos graph. Now it is time for the tan graph. So I'm going to grab this one from the book, and it's asking us to sketch y equals 1/2 tan x on 2 minus 1 for x is between 0 and pi, and it wants us to state the period as well. So state the period. State the period. In the last video, I forgot to tell you what the amplitude and period were. So just a little side note for the last video. The graph was y equals 3 cos 3 theta plus pi on 3. Just so you can check, the amplitude is of course 3, and the period works out to be 2 pi on 3. So just for the previous example, I forgot to state that, and the question asked me to state that. So I need to read my questions carefully. So we want to sketch this graph. Firstly, what's the amplitude of this graph? Trick question, no amplitude. It's a tan graph, no amplitude. We've been over this. Don't get tricked. It has no amplitude. It has no amplitude. I'm going to say it one more time. Tan graphs have no amplitude. There's no amplitude here. That's why it's just saying state the period. Well, let's do dilation, reflection, translation. All right, dilation by a factor of 1/2 from the x-axis. Let's see, we've got another dilation we do. So the coefficient of x here is actually a half. So this is equivalent to writing, this thing in here is equivalent to writing half of x. So dividing by 2 is the same as saying half of something. So that's why these two are equivalent. So the dilation here is going to be the reciprocal of that, so it's a factor of 2 from the y-axis. Any reflections? No, but we do have a translation of 1 unit down. Okay, let's draw our mini graphs. The basic shape for your tan graph, if you remember, it has several asymptotes actually. Kind of does something like this, and so on. So that there is pi. So for y equals tan x, that there's pi, and that first asymptote is at pi on 2. So I'm just going to take this section there, and we're going to do our DRT. So dilation by a factor of a half from the x-axis. Tell you what, I'm going to leave that because it's not going to do much to the graph, but it's just going to make it like go slightly closer to the x-axis. So I'll draw it over if you're wondering what that actually does. It's kind of going to do this. It's going to get closer to the x-axis, and of course I'm not touching my asymptotes. Alright, dilation by a factor of 2 from the y-axis. So that means it's going from the y-axis, so each x value gets multiplied by 2. Let's sketch that. Well, if that's pi there, and it's getting multiplied by 2, it's going to go like this. So that's going to become 2 pi. And pi on 2 times 2, well, that's pi. So there's our asymptote. And it's going to be translated 1 unit down. So let's sketch that. Let's sketch that. So it's going to start there. And it's going to do... So I'm just sketching one period for now. And that endpoint is going to be at 2 pi. I'm just putting that in arbitrarily, remember? I'm just drawing like one cycle. And that's pi there. This x-intercept, well, if this is a non-calculator question, it's not, but suppose it was, if you're trying to solve for the x-intercept, it's going to be an exact value. And they wouldn't ask you in this sort of question if it's non-calculator. If it was calculator, they might ask you for a decimal. Look, I'm going to find it anyway, just because it's good practice. I'm going to find that x-intercept. So x-intercept, make y equals 0. 0 equals half tan negative 1 x on 2 minus 1. Now if I solve for x, it's going to look something like this. So that's going to jump over there. It's going to times by 2. So x is going to equal, and I'm going to do this all in one step. I'm happy for you to take a lot of steps. It's going to be tan of 2 times 2. That would be your answer. And the reason is there's no exact value for tan of 2. So that would be the exact value there. That's what you would take as the x-intercept. The question doesn't really ask us to do that if you look at the worked examples. So we'll leave that x-intercept out. Let's see, so it's from 0 to pi. Well, that asymptote's at pi. So from 0 to pi, that's the only bit that we need to sketch there. That's the only bit. Alright. So let's have a sketch. And I'm going to put in the x-intercept anyway, because I'm a very, very good student. Unlikely that you'll have to. Unlikely you'll see it, but let's be consistent. It's better to be safe than sorry, right? Let's do it. So I'm going to rule up my axes. Here we are. Nice big axes as always. There's x, there's y, and I'm going to need my ruler back because I need to put in an asymptote at x equals pi. Need to have that asymptote in there. At x equals pi, there's our asymptote, x equals pi. Right there. Alright, and here's our starting point. Let's sketch this. Remember, there's no amplitude. And that's an asymptote, so we're not going to touch it. Make sure you don't touch your asymptote. You know this stuff. So what's this point here? Well, here it was 0, 0, and it got translated 1 unit down. So it's going to be 0, negative 1. Let's check if we're right. Well, that's a y-intercept, so we're going to make x equals 0. So I'm going to prove to you that it's right by doing it another way. Y equals half tan, well, 0 divided by 2 is 0. Tan of 0 is 0, so that's negative 1. Beautiful, we've got that right. Got our asymptote right. And just to be a fuss pot, I'm going to label that. So that is 2 tan of 2, 0. That's our x-intercept. That's about as thorough as you'll need to be. Ooh, we need to state the period. So the period should be 2 pi, because this is half a period. The period should be 2 pi. Let's check. Well, to do the period calculation, period equals pi on n for a tan graph equals pi on n is 1/2. The 2 jumps to the top. We get 2 pi on 1, which equals 2 pi. Fantastic. There's our period. So that's our graph. And just to confirm, let's jump over to Desmos so I can do a quick check. Let's make sure we've got the graph right. So you can do this on your graphics. So y equals 1 on 2 times tan x on 2 minus 1. Let's check. So yeah, it's got that point 0, 1, 2.214. That must be 2 times tan of 2. and we can see our asymptote is there. Alright, let's go back to our graph. Let's make sure, in fact, let's restrict the domain. So you can restrict the domain on these things by going from, you can do this, 0 to pi. Beautiful. Looks exactly like our graph. Back to our graph, yep. Fantastic. Alright, that's our answer. And if you have been, thank you for watching.